get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in the importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
Hello, good morning, good afternoon, good evening, wherever you are in the world. This is the Ask an OpenShift Expert live stream. I'm Jonny Rickard, and I'm finally back in the saddle with my boy Sully. How you doing, man?
I am doing really good. It is good to be back after we were saying in the pre-show. It's been like a month of Sundays since I was here, so it's really good to be back. I'm glad that we are finally entering the summer doldrums. I say that very much tongue-in-cheek because it's not like things are idle or boring. We were also chatting. I just deployed this morning the OpenShift MCP server in my cluster, so I've been experimenting with that. So definitely not boring. Lots of really cool stuff going on.
Nice. And it's famous last words that you said it's going to be, the summer kind of like lay down where now it's just going to spike back up for you.
So my wife works in healthcare, right? And the Q word, right? Quiet is the word that you don't use.
Oh yeah.
As soon as you say, "Oh yes, it's quiet," that's when things go absolutely bonkers and it gets chaotic. So I have been well trained not to use that word. Knock on wood, even though I just did.
Absolutely. Yeah. It's like, why would you say it out loud? No.
Yeah. All the memes on the internet about the nurse walks up to the nursing station, is like, "Wow, it's really quiet," and like immediately gets death glares from all of the others. Yeah, that's
Absolutely. Well, hey, everybody that's watching, we're joined by Brian and Martin from CloudCasa. So, hey, Brian, do you want to go ahead and introduce yourself really quick?
Yeah, sure. My name is Brian Sietsma. I run sales here at CloudCasa for North America and South America. I was laughing. I was going to say that's the look my wife gives me when I say it's too quiet at our house because we don't know where my daughters are. Yeah, it's good to be back. We were here together, I think, a little bit over a year ago. But looking forward to reconnecting again.
Yeah, nice. Awesome.
Hi, everyone. My name is Martin Fawn. I'm a field CTO here for the Americas. I'm actually supporting Brian as a technical sales engineer, so field architect here at CloudCasa. Nice to meet everyone and glad to be back on the show.
Yeah, awesome. Glad to have you guys. And thanks for reaching out and setting this up and coming on the stream. Like, we're really excited to have you guys. Like, my team personally has been doing a lot of work with different DR products and stuff like that. So I'm really interested in this topic. Before we get started, let's do some top of mind things. The first one is what's new with 422 dropped last week or week before. I can't remember is when the stream was. It's the stable channel has 422 available, but it's not out in the upgrade path yet. So if you wanted to update to 422, you could go through the fast channel. It's a fully supported update path. So you could go from 421, use fast, go to 422, and then once stable releases, you can upgrade it into the 422 stable. But just so you know, it's out there, it's available, or you can pull the stable packages down directly from the mirror and go directly at it. In addition to that,
I'll add on, Jonny.
Go ahead.
My world is mostly OpenShift virtualization these days. So OpenShift Virt 422 also shipped. If you haven't looked at it in a while, when you upgrade your cluster, if you deploy a new cluster, there's been some pretty significant UI changes inside of there. So the networking stuff is getting better. Now both the node network and the virtual machine network abstraction wizards are there, which it's an abstraction for creating an OVS and cluster UDN for connecting to VLAN back networks. So that stuff's there. The first iteration of combining templates and instance types. So there's a new create VM wizards experience that's in there. Alan on my team, we were experimenting with it over the last couple of days and have found some quirks that we will be providing into the UI team. But overall, it's really good. It looks really nice. It's great to see us standardizing on those and consolidating them because it was a little confusing to have two different ways of creating VMs. Anyways, there's a ton of stuff that happens not just in Virt, but across the entire OpenShift set of things. Keep in mind, I don't know how much we talk about this publicly, but there's like 4 different types of operators because there's like core operators, which are the ones that are platform operators, I think is what we call them, which are the ones that ship like as a part of OpenShift itself. So when there's OpenShift 4.22.3, those operators are always a part of that package. And then there's platform-aligned operators, which have their own release cycle that's within a month of the core or the platform, release cycle. So OpenShift Virtualization is platform aligned. 4.22 shipped, and then 2 weeks later, OpenShift Virtualization 4.22 shipped. For the decoupled ones, like OpenShift logging is one of them. Has its own version number, its own release cycle.
ACM.
Yeah, ACM's another one. I forget what the fourth type are, but they're basically completely not aligned at all in any way, shape, or form. They're not decoupled, but they're not aligned or something like that. I'd have to go back and look. It's all in the docs somewhere.
Yeah, awesome. Yeah, and speaking of that, I was actually I knew ACM offhand because I was reading one of the announcements, and ACM 2.17 dropped at the end of June. And so that's got a bunch of enhancements and stuff like that. So the big one that I took away from that is like within OpenShift virtualization, now there's like more fine-grained RBAC, role-based access control, which is really nice. So we'll have to play around with that. Actually, I was telling you in the pre-show, like I haven't really like dug into much recently. So it's something that I'd like to dig into and just trying to get a lay of the land now and see what it's looking like these days.
Yeah, I'm catching up on a bunch of things, ACM included. I've spent the last 6 weeks for me, in addition to Summit, 8 weeks, I guess, in addition to Summit, have been like analyst things and just responding to inquiries and filling out questionnaires and creating demos and delivering demos and all that other stuff in support of all the analyst activities. But the other thing that we've been doing a lot of work on is I'm creating agentic workflows for a lot of different things. So like I can connect into Slack and look at my messages and determine like patterns inside of there, and then use that to generate FAQs and et cetera. So trying to create agentic pipelines to accelerate the ability to basically respond to questions both internally and externally. So other fun things that I've been working on.
Yeah, that's awesome.
I just haven't circled back around to actually get hands-on with the product
Yeah.
yet.
Let's see here. I think that was it for me. Like it was ACM 4.22. Yeah, I think that's it. We have our schedule next week. We have Portworx, and then we're still trying to find some topics for the end of the month. And then I talked to Aubrey, I think last week or week before, and she mentioned some of the demos that had gone down at KubeCon. So was it KubeCon? Whatever it was. And then so then we're gonna reach out to some of those guys and try and get some of those demos done. I know Sully, you did some networking and storage ones that we're gonna try and circle back to and get in place. So if you're watching and you have ideas or requests, please hit us up, Jonny at redhat.com and Sully at redhat.com. We definitely love the ideas, and if we could do a stream based off of your input, yeah, we'd love to, I think, take a swing at it.
Yeah, if we don't have a topic, or maybe we can even squeeze it in with another topic, I really want to show off some of the MCP stuff that I've been working with, because it's really interesting to interact with the cluster and basically say, Claude or Gemini or ChatGPT or whatever, whatever tool I'm working with, like give me a cluster health report, and it spits back out information about what's happening in the cluster and what I should care about and stuff like that.
That is awesome. That is awesome.
I'm interested. I'm having fun experimenting with it now, and I'm interested to learn more.
Nice. All right, Brian. All right, Martin. I'm sure you guys are tired of hearing us yammering on. Do you guys want to go ahead and kick it off?
Yeah, sure. Let me share my screen. So again, for those that have been loyal listeners, this may be a little bit of a review to start. I want to just talk a little bit about who CloudCasa is, and then progress through backup and recovery, and then disaster recovery, which we're going to focus the majority of the time on. But I wanted to just give a quick overview. So who we are, we're a data protection company. We've been in the data protection space for really almost 50 years. Back then, those backup and recovery conversations were mostly focused on physical environments, VMware, Hyper-V. We seen the transition of folks moving from physical into virtualization and now eventually into containerization. And so over that life cycle, we've had a handful of other backup solutions that have been designed for some of these other niche use cases. But one of the big kind of events in our life, we had a product called ECX, and that we were OEMing with IBM. And in 2021, they went ahead and purchased that product line and about 200 of our employees. And with that purchase, we said, what's the next emerging market that really needs a data protection solution? And so that was very clearly Kubernetes. From there, we struck out on creating this data protection solution designed for any flavor of Kubernetes. And that's where CloudCasa came from, right? So today, CloudCasa protects any version of Kubernetes. We offer both SaaS and self-hosted. It's designed for backup and recovery of your containerized workloads. And when we created this, we said, what's looking at the market? What are the challenges that Kubernetes users, especially new Kubernetes users, are going to have when they are looking for a way to take advantage of the benefits that OpenShift offers, right? The scalability, the code portability, all those great things that come with containers. How do we allow them to better leverage those things by moving more of their production, more of their critical workloads over to containers, right? And so when we talk about data protection, there's a handful of challenges, a handful of ways that you can kind of tackle that challenge, right? There, you can do it yourself. We have everybody in the industry knows Valero. Red Hat has OADP. This is the open source version of Valero that allows you to build backup and recovery jobs. It's great for what it is. It offers the basic level backup and restore that some customers might be able to utilize, but there's some shortcomings that come along with that, right? Having an open source solution that's designed for single clusters. As soon as you start scaling out that environment and talking about, hey, if this is critical data, I really need to have some sort of enterprise support. I don't want to have my customers' data go down in the middle of the night and rely on community support for that, right? So that's the do-it-yourself option. Then we have these two other options, right? That's something that's kind of bolted on to your existing backup suite. There's dozens and dozens of options out there that protect more legacy environments, physical environments, VMware and Hyper-V. And a lot of times when customers look to take that leap into, say, OpenShift virtualization and transition away from VMware, oftentimes those legacy or those enterprise backup solutions that already are in place claim to have some level of support for containers and for OpenShift. And when you're going that route, yes, that oftentimes is the incumbent, but along with that comes a lot of complexity. It's very heavy from a deployment and administrative perspective, and it's oftentimes very costly. And in addition to that, and we've heard this several times from our customers, hey, we went ahead and did an OpenShift virtualization POC. We loved it. We went ahead and did a purchase. Our existing backup tool told us that we'd be able to back up and restore these OpenShift workloads. And then when they get to that point on day two where a restore is needed, it doesn't have the capability that they promised. And so I have one customer in particular that just invested in a large ROSA environment, and their existing solution had promised them, hey, this is going to work. We support this. And then once they got their ROSA environment set up, they started moving VMs over there, and they found out this backup solution couldn't even connect to ROSA. And so if you're looking at this second option, just make sure that before you go ahead and make that transition, make that investment, that backup solution does offer you the support that you need, whether that's namespace level backup and recovery, VM level backup and recovery. If you need something as granular as something like a single file, make sure that solution is able to offer you the support that you need for your use case. And then the final option on here, people go ahead and buy a purpose-built leader, right? There's a handful of solutions out there that are designed for Kubernetes, and CloudCasa is one of those solutions. The other alternatives on the market, you'll recognize the names like Casa and Portworx, right, which are great solutions for what they offer. They do provide this support for OpenShift, but there's a lot of things to just keep in mind as you do that. Oftentimes, those solutions are very, very cost prohibitive, right? They're expensive. And so what we said when we created CloudCasa, how to address all three of these challenges, was to create a simple solution that's not a major lift for people that might not be Kubernetes experts, that gives you an intuitive UI, it gives you enterprise support, but it's also going to give you things like VM level backup and recovery from VMs in OpenShift virtualization, give you things like backup to object storage, NFS, and SMB, gives you options as to what underlying storage you're going to be using, but also give it at a price point that is very easy to manage. So we are by far the most cost-effective solution when it comes to backup recovery and DR in the space. At the bottom here, you'll see we're offered at $69 per worker node per month. Compare that to something like Kasten, which is $185, $190 per worker node per month. And you'll be able to see that the savings that you're going to be looking to make by, say, moving away from VMware, you'll be able to carry that over. Check a lot of those boxes with CloudCasa that you need and continue things that CloudCasa offers to solve those problems, right? We, from a single pane of glass, give you the capability to back up and restore OpenShift clusters, namespaces, all the way down to the VM and file level. A lot of times these solutions make you have separate solutions for containerized workloads and the VMs. CloudCasa gives you that single pane of glass, a single easy to use UI that, again, is easy enough for your admin from VMware to go ahead and manage your backup and restores, right? And so this also offers immutability, both during snapshots and at the destination. I'll talk about disaster recovery at the end here because we're going to go into that in more detail. But one of the great things about CloudCasa is the ability to support any flavor of Kubernetes, right? So we're agnostic when it comes to which Kubernetes platforms we support, which allows for things like migrating clusters from, say, Rancher or Tanzu into OpenShift, or OpenShift on-premise into ARO or ROSA. It allows for the ability to have more of a hybrid strategy for your containerized workloads and give you the ability to do migration and replication between those destinations.
So
Also
Brian,
wanted to focus on, yeah, go ahead. Yeah.
So kind of taking a step back, or maybe a step up for a moment. So at a high level, OpenShift and really Kubernetes, right? There's the backup concept is very different than what we think of when we think of like a guest OS and a virtual machine, or even a virtualization type environment or something like that. In that, in my mind, there's sort of three different ways that applications get protected inside of a Kubernetes deployment. So one is application level protection, right? I've got a database in a pod, and that database does periodic dumps of its data, a MySQL export or something like that, and it gets shoved off somewhere. Right? OpenShift does this with etcd. Right? If you have the etcd backup job configured, right, it goes in and it does an etcd dump, and it puts that into a PVC somewhere, and now I have my application data protected. Importantly, that doesn't protect the Kubernetes, the API objects that represent that application, right? That has to be done separately. Oftentimes that's something like I'm using GitOps in order to deploy my application, so I don't need to protect my application definitions, the metadata, the YAML objects separately, because it's already in my GitOps deployment. So two is something that works at the platform level in order to protect both the one and or both of those metadata objects, so the YAML pod definitions or deployment definitions, the routes, the services, so on and so forth, as well as the PVC data. And that PVC data can be protected in a few different ways, right? Valero just pulls it out and shoves it into an S3 object store, for example. And then the third one is what we see from our storage partners is basically protecting the volumes, the storage volumes that are the PVCs. And to your point, there is a few storage vendors who have things that are capable of, they're Kubernetes aware and can protect those objects. But it's you have to meet in the middle, right? Just protecting the data within the application isn't sufficient to recover the application. Just protecting the PVC underneath that isn't sufficient to protect or recover the application. You need all of those components in there. And so I think that that's different than a lot of people think with, and I'll pick on VMware here, because I think that's what most people are familiar with. Hey, I use, Veeam, I use Commvault, I use, whatever. They're all really good at protecting, especially VMware virtual machines, because it's a data store. And in that data store is one folder that has the VMX definition, that has, the VMDKs that are the VM disks and all those other things. So it's pretty straightforward to protect. But Kubernetes, of course, is just different in that regard. So I definitely want to point out why this is different, why we see these different things that are happening inside of there, and highlight OpenShift doesn't have we have OADP, but we don't have a backup suite. Right? As you pointed out, OADP is a tool that can be used to protect that data, but it's not this coordinated, full-featured, full functionality backup suite that you might expect for protecting applications.
Yeah, can we completely agree with that, Sully? And that's a great point that you bring up, right? Kubernetes completely changed the data protection, not just the infrastructure landscape, but the data protection landscape as well, where rather than having these servers and persistent data on VMDK or virtual disk storage, we now have a completely separate construct of persistent volume claims and persistent volumes that can be mounted pretty much anywhere, right? From a data protection standpoint, that changes the game entirely from users that maybe are just dipping their toes in stateless workloads with Kubernetes and OpenShift. They can reinstitute an environment just from the YAML configuration, right? So just create their application pod objects as well. It's when we start talking about, okay, now we need to protect that persistent data, the persistent volume claims. How do we go about doing that? Especially as users are now, tacking on OpenShift virtualization and more stateful workloads to their environment. How do they handle those types of databases? And with that application suite and what we have with CloudCasa, we now have that database integration. We have the ability to lock in and quiesce databases before a storage snapshot, solve them after our snapshot's done in order to take that application consistent snap. And we start out with that backup of the stateful workload, backup of the persistent volume claim, wrapped around kind of this multi-tenant RBAC type implementation where users are able to back up and protect their own stuff. And now we're seeing that there are other ways in which we can take advantage of, let's say, storage replications, right, for disaster recovery. If I'm using storage that's able to mirror all of my persistent volumes over to another storage array of the same type, I have the ability to now just bring up and mount those persistent volume claims over there. Easier said than done, obviously, right? Because it's we need to know the just the underlying topologies of the storage arrays and the storage relationships, and that's really what CloudCasa has been designed to do from a DR perspective now. So as we move forward in terms of just backup recovery and migration, looking more towards disaster recovery, how we fail over, fail back. These are some of the integrations that we're going to be taking advantage of in our disaster recovery play.
Yeah, I wasn't going to go there yet until we get more into the VM side of things, because things to your point, right? By default, there is no differential or incremental backup, right? A PVC, you create a snapshot, and usually that's what a backup software will look at, or OADP, right? It pulls that data. It is a full backup every single time, and you have to rely on some other trickery at the hopefully your storage vendor, and your storage vendor, you can coordinate with that. And to your point with CloudCasa, I know that's the stuff that y'all are working on. is how do we do those coordinated things? How do we make efficient backups as opposed to everything always being a full copy?
Yep, absolutely. And I know that Red Hat is also working on some change block tracking, journaling type initiatives with their persistent volumes as well. Everyone's going to have their own implementation of their storage spec, the CSI storage spec. We have different ways in which we can access data in order to block level incremental for them, be able to do single file recoveries from the snapshots as well. So in other words, mount up that PVC and just pull out those data blocks that correspond to the file names that you request, right? So there's going to be a lot of powerful features from a data protection backup recovery perspective that users that are familiar with traditional backup applications, when they make that shift over from a traditional hypervisor to a cloud native containerized virtual solution, virtual machine solution, they're going to have those same benefits of granular file recovery, application integration, and that's really the whole purpose behind CloudCasa.
Yeah.
Right. Our goal for you, the listeners, right, as OpenShift admins, is to help you identify other areas where you can better take advantage of what you have with OpenShift. I talk oftentimes about this one account that we have where we got introduced to the account because they had a small OpenShift environment, 8 or 9 worker nodes. They had a handful of stateless workloads, but they had an initiative from up top that said, hey, let's move some of these more critical workloads over to OpenShift. But in order to do that, they needed to have a more enterprise ready, a more reliable backup solution to make sure that customer data was being protected, right? And so they started their CloudCasa POC. By the time that they completed and went ahead and purchased CloudCasa, they had more than doubled their OpenShift environment because they saw that this was a way they can move more of their workloads into OpenShift to take advantage of the benefits that OpenShift has to offer. And now that they've been a customer of ours for a year now, they're looking to move their MySQL applications over to OpenShift. They're looking to move away from VMware and move their VMs into OpenShift virtualization. And it helps, again, you guys to save money in terms of looking at other ways to utilize OpenShift, because CloudCasa gives that cost-effective solution for all different layers of that data protection onion, right? And so, yeah, thanks, guys. That's great additional information. I want to just touch on a couple things in terms of our partnership with, right? So we do today offer, like I said, a SaaS offering as well as self-hosted. That self-hosted version is great for environments that won't be able to use SaaS. Maybe you're a European customer, a finance, maybe you're in government and you need to have an air-gapped environment. That self-hosted solution offers that. We do support every flavor of OpenShift today, whether that's on-premise OCP, if it's OpenShift virtualization, OVE, ARO or ROSA, as I mentioned. And so that gives you the ability to, again, take advantage of OpenShift and all the different layers that it has to offer. If you have an initiative to have more of a hybrid environment, we can help with the migration to and from on-premise to cloud. And then, again, provide that at the lowest TCO. How do we give you a solution that's cost-effective, that's not going to be difficult to use, and fits gives you complete protection for your OpenShift environment. So again, everything we've been talking about today has been so far mostly focused on backup and restore, right? But when we talk about covering data protection, especially compared to what users are used to having with VMware, the other piece of that is disaster recovery, right? How do we make sure that if a disaster happens, we have a very simple way to fail over and fail back to our DR site? And so what we have announced earlier this year, actually a couple weeks ago out at HPE Discover, was a new way to provide disaster recovery for OpenShift running on supported storage. So when we talk about DR, there's not many options out there that could replace something like a VMware SRM or a Zerto, right? If you're looking for a way to make sure that your copies are being replicated to a DR site and available for failover, that's where CloudCasa is looking to extend that data protection capability. And so what we're going to be doing and what we're going to be continuing to doing over the next several months is extending this storage DR capability. Martin alluded to it earlier, but it's the ability to leverage the underlying storage and their replication capabilities to provide failover and failback of the OpenShift workloads. So if OpenShift is running today on HPE Electra, we have the ability to drive and manage the DR plans and recovery plans using by kind of orchestrating the storage replication. And so Martin can go into that in more detail in a minute, but to give an idea, HPE is supported today. By the end of this month, we will be adding Dell PowerStore to that, and we'll be extending that out to other storage providers as this builds. So something to keep in mind if you're looking for a way to say replace the DR solution you had with VMware and you're looking to make that switch to OpenShift virtualization, this is a great way to utilize the storage you've already invested in without adding additional layers in at the software defined layer, things that might clog up and slow down your backup and restore jobs. Leverage that underlying storage and their replication capabilities to manage the failover and failback. So Martin, do you mind just doing a quick overview of the process here, and then we can jump over to a demonstration?
Certainly. Yeah, so what you see here on the slide in terms of architecture is we have two sites, right? So we have a primary site over here on the left-hand side. We have a secondary site on the right-hand side here. And each of these sites are running their own OpenShift clusters. They might be running OpenShift virtualization here with their own pods and VMs running on OpenShift virtualization. What you're going to see is, normally this top layer, we'd install our CloudCasa agent. If you're self-hosting CloudCasa, we can potentially install our CloudCasa server as well to manage these workloads. But normally you'd just be talking about a CloudCasa agent that is performing let's say, or you'd have installed on each site here. Now, if you want to do failover and failback between these sites, right, between those CloudCasa agents, what we need is essentially a cluster state sync status, right? So our agent is doing this automatically from a backup and recovery, disaster recovery perspective, where we're syncing the status between both clusters. But the main part of this is what's happening on the storage side. So you're going to have these applications living on these OpenShift clusters at the top here. They're going to be living off of persistent volume claims that are going to be attached to one of these supported storage arrays that we have. So initially we had to build up this framework in which we could scan in the storage arrays at the primary and secondary sites. But once we have that framework, once we have that framework implemented here, adding storage is just a matter of making sure we're properly integrating with and calling the correct APIs through that framework. So we initially supported Longhorn Electra, and we're going to be releasing Dell PowerStore in the future, but or within the month here. But essentially what's happening is that storage is going to be replicating copies to its applicable disaster recovery volume. So imagine you provision a persistent volume at your primary site. You're already using storage replication to replicate that to a DR volume. And what our agent is going to pick up on is it's going to see that storage relationship happening in the background. And you're going to be able to find failover and failback plans to initiate a failover. Let's say if primary site, an application on your primary site goes down, we're going to be able to easily fail that over to your secondary site just by attaching to the replicated disaster recovery volume. So all that magic that occurs while you're provisioning your application and your storage, that all happens on the back end there. And we're also going to be able to take advantage of some of the restore capabilities that we built into the CloudCasa application from the get-go, right? In terms of the application integration, the ability to transform the restore so that your application is going to be able to run at your secondary site, changing around, let's say, labels or renaming namespaces, changing networking configuration, that type of thing, so that when the application, you do run and click the button to fail over the application. It handles all those restore transforms in the back end for you, and now your application is running up on your secondary site. And failback is just the same way, right? We have our DR volume now replicating back to our primary storage volume or the primary storage volume array. That's getting synced back to the primary storage volume, and now you can execute your failback plan to bring up your application at the primary site and link to all those persistent volumes that are running on your primary storage array. So hopefully that all makes sense, but it should make more sense within the demo that we're going to show here in a little bit.
And Martin, real quick, just you said it does all the backend transforms. So is that saying that like if your deployment is called primary and you're failing over to the secondary or DR, it'll change all the names underneath, like so your deployment name will now be like DR dash whatever, so that we don't have to worry about it, but just a pointer back to it, or you know what I mean?
You have that option, right? So, okay. Yeah. So by default, it's going to try and use the same names that were on your primary sites, the same network configuration. But in our UI, you have the ability to perform those restore transforms. Make those customizations by uploading new YAML to override the existing YAML definitions that are encountered within the resource definition.
Okay, and then on your primary cluster, after the failover is done, does it actually remove the workload from the primary, or does it run them kind of both in tandem, but just disconnected from the sync?
In the future, it will. Right now, it's just assuming it's going to run in tandem. We don't do anything on the primary site at this point. We're just assuming it's down. So these are workloads that you need to run manually at this point in order to accommodate the failover and failback. But this is, you say it's one of those things where you set up once, you click a button, run the failover plan, and then we're just going to handle it on the secondary site. And I think as we move on towards future implementations of this, that's where we're probably going to have some type of heartbeat or high availability type implementation added to this architecture as well.
Gotcha. Okay, cool.
And there's a question in chat from PopsTech. So does it support K3s and single node deployments?
It does, yes. So it doesn't have to be OpenShift. It can be any certified deployment of Kubernetes. And really for the disaster recovery piece of it, we're still in the process of working with the storage vendors themselves. So we're not building our own storage provisioner here. And in this case, we're relying on the same storage provisioner that's available and storage driver that's available from HPE, Electra that's available from Dell. We're working with the plan is to incorporate as many storage vendors as possible that are willing to work with us. NetApp Trident as an example. So long as your storage supports, our is supported within CloudCasa, and even if it isn't, just let us know. We're going to do the legwork to try and figure out how we get those API calls into our CloudCasa platform now that the framework has been built out.
And does CloudCasa, I want to say, does it care? But I think the proper way to describe it is, does it do any testing or validation or anything like that of like source and destination compatibility? So, for example, my source is OpenShift 4.20. My destination is OpenShift 4.14. Right? There's significant API differences, or even my source is quote unquote vanilla upstream Kubernetes. My destination is OpenShift. Anything like that, or is it just it creates API objects and it's up to you, the administrator, to make sure it all works?
Yeah, that's a great point too. So yeah, it's we're going to allow, our platform is going to allow you to perform those types of restores, like between different versions of Kubernetes and different deployments. In fact, some of the customers that Brian has been referring to have been using CloudCasa as their test migration toolkit to see if they could properly upgrade, from 1.3.2 version Kubernetes to 1.3.6 as an example, right? Or if they need to upgrade some of the resource definitions beforehand, right? All we're doing is we're making calls to the Kube API server to reinstantiate those resource definitions. So if your cluster doesn't,
it feels like the smart move.
Yeah,
I can't imagine the testing matrix of trying to
validate exactly. So we're not, but it is a great platform that we can use to perform those tests. We're not going to run any underlying tests underneath that beyond but we are going to show those errors. Hey, we don't know, this cluster doesn't know what a VM object is, as an example, if it doesn't have KubeVirt or OpenShift virtualization operators installed on top of it.
Yeah.
So
that's a good point, right? Of if the CRDs aren't there, it's not checking. So it's going to try and create those things, but that doesn't necessarily mean that it's successful. And so
exactly. Yep.
Thank you.
Yeah, and keep in mind, right? This storage DR feature that we're talking about is in addition to the backup and restore that we reviewed ahead of time. Typically with CloudCasa, we do not care where your Kubernetes resides, what type of storage it sits on. We can do backup and restore, as well as continuous backup and restore and replication, regardless of the underlying storage. For storage DR in particular, this is an addition, this is an add-on to our CloudCasa backup service. And so this requires the supported underlying storage, because that's, again, what's driving the replication. So we can do in-place replication, and other solutions will call that their DR, right? Where we can do continuous backup and restore from primary to secondary. And that's something you can do regardless of the underlying storage. But again, for failover and failback, this storage DR capability, it's dependent on the storage. And in this case, HP, Electra, and then Dell in the near future. All right, and Martin will cover that in some more detail here. But before passing it back to Martin, just wanted to touch on the licensing models here. As we said, the idea is to provide the most cost-effective solution. What we're seeing is our backup and restore pricing. We will have a separate SKU for storage DR. But again, the idea is to be half of or less than half of what you are paying with an alternative. If you look at, say, Portworx, for example, we're going to be about half the price of Portworx for DR and about a third of the price for Kasten for backup and restore. And again, that's what's great about this, is now you have a single solution at half the cost that does backup and restore well as DR. And so you have both of those different areas of data protection being provided for you in a single pane of glass for both containers and VMs. So Martin, I'll stop sharing. I'll pass it off to you. And in the meantime, if there's other questions, feel free to throw them in chat.
Yeah, appreciate that, Brian. So let me share out my desktop here, take you through some of the integrations that we have with Red Hat OpenShift, and hopefully y'all can see my screen now, and I think I can see my own screen, so I'm going to assume that I'm good to go here. But yeah, we'll start out here on the OpenShift console, right? So hopefully some of you are familiar with this console. You've been moving or migrating your workloads over to containers and pods on OpenShift. Maybe you might be taking advantage of OpenShift virtualization as well, moving VMs from traditional hypervisors to containerized VMs. Now comes the day 2 operation. You're going to be looking to protect all this stuff, and as we mentioned, data protection has changed within this cloud-native containerized world here. So fortunately, we've made it as simple as possible to get deployed here with regards to our installation methods, right? So we can install through Helm, kubectl statements, but if you're just in OpenShift here, you're looking for a disaster recovery plan or applications that can handle disaster recovery, you can just type that into your operator hub here. So think of this as a marketplace, right, where you can see our CloudCasa operator. This is our agent that you can install, deploy to your OpenShift cluster. And that agent is going to tell us all about your cluster, right? It's going to tell us, if you're running virtual machines, the virtualization container engine, you can tell us the namespace and underlying network topology layers. That's what we can pick up from that agent. You can also do search for backup migration, right? So you'll see our CloudCasa agent with respect to that. So once you have, our agent installed on your cluster here, defining a backup is just a matter of interacting with the CloudCasa user interface. And we have 2 versions of CloudCasa. We have our SaaS portal, we're built for Kubernetes in Kubernetes, right? So the CloudCasa itself is a Kubernetes pod that's running in the cloud. You can access our URL here at cloudcasa.io, sign in to the portal or sign up for an account via this Try It Now. If you do have more restrictive, air gap requirements where you're not able to traverse the internet or network, we do have our own self-hosted version of CloudCasa where we provide you access with our image repositories. You can download our image repositories, our Helm charts, and just deploy your own CloudCasa server within your own OpenShift cluster there. So let's go ahead and sign in here. And when we sign in, we're going to see, just an overview of the environment, right? So this is the CloudCasa management console here, showing you the number of clusters that are under management, the amount of data that's being backed up and protected, any type of cloud providers that we might be integrated with, any type of alerts or system notifications, backups that we've completed here. I'm logged in as my own username here under Martin CalLogic Demo is my organization, but this is a multi-tenanted application, right? So we can switch between organizations. Let's say you have several different customers that you might be managing the backups for. You can switch between those organizations. Let's say I want to take a look at some of the clusters under management and in my development organization here. So you can see what's happening just by easily switching between organizations that you're involved with, right? Just to quickly review here, because I know we went through some of this on our last call, but adding a cluster, assuming you don't have a cluster already added, is just as simple as installing that agent. You can also add the cluster through here. We have our OpenShift bare metal cluster already added, and we can define backups of VMs and namespaces just by creating a backup job, right? So under our backup, you select what you want to back up. By namespaces, we can look at VMs that are living on that cluster as well. So we're detecting where, the libvirt engine has been deployed, where you can see the list of VMs that are running on this cluster, and that should correspond to the list of VMs that are running here within our OpenShift virtualization console. So so we can select the VM that we want to back up here. In this case, I want to back up some VM, confirm that, choose how I want to back it up. So this is by primarily a CSI snapshot, but you can configure different backup methods depending on storage classes. Let's say you're not able to use a CSI snapshot because it's residing on NFS storage, where CSI has no play or is not applicable. And you just define it like you would a regular backup, right? So we don't, you don't necessarily have to care about the underlying topology of, where those resources are located, on which persistent volumes. You're just defining a backup job as you would a traditional backup application. But because it speaks the language of cloud native, and because it speaks the language of Kubernetes, we're going to ensure that, what you back up, the CRD resource definitions, the YAML definitions from etcd, the persistent volume data on your cluster. We're going to be able to allow users to provision their own storage, right? Either at an object or file storage destination. You're going to be able to provision that all through the user interface from there, and define your backup as you normally would in a traditional backup application. This can be extended from backups and restores to migration to replications, right? Because everything's cloud native. Let's say you're running applications on the edge, you want to replicate that to a centralized site, HQ. You can define replication jobs or maybe one-time migration jobs. This is all built into this backup and restore world. And then from a recovery perspective, right, this is where we're going to talk about getting down to the nitty-gritty of what we can restore, right? So if you wanted to, let's say, restore the entire VM, right, you can just select that VM from the catalog. These are all of our snapshot backups that we've taken. They're copies to separate destinations, but now we're going to be able to define what we want to restore. So that could be at the resource definition level here, so we can use our recovery point browser to expand virtual machines that we want to recover. Here in this case, I want to recover my example VM, and we're going to have all the configuration, the definition from the YAML file that you can use as well, just to verify here. This is where we're also going to be able to override some of these definitions as well. or if you want to recover individual files from that PVC or from that VM, you're going to see those options listed here in terms of your restore job definition. So this is, what we've always had. I think this is a good review of some of the things that we had talked about in our last call with respect to backup and recovery, migration, and replication. But now we want to get into this new concept of disaster recovery, because that's what we've been hearing a lot about when users are moving towards cloud native. All the tools that they've had from a disaster recovery perspective, spinning up VMs, spinning up applications to a secondary site, are not going to be available within Kubernetes, right? You might have to piece them together yourselves through storage mirroring, storage replication pieces that you have running in the background, but then perform manual steps in order to ensure that that application is working on the destination side. In this case, we've actually introduced a DR tab here, which is going to allow you to, and I'm going to jump to a different session here, which is going to show some storage systems that we have added to CloudCasa, right? This could be your Dell systems, your HPE, Electra systems, your Longhorn systems, right? These are the storage systems that we're supporting today, or will support with it in the coming month. And this is just a glimpse of some of the Dell PowerStore integration, but it's going to work exactly the same way as it, or very similar to the HPE storage and the Longhorn storage source and targets. But what you're going to do here is, so long as we know about that storage system on which those persistent volume claims reside, you scan in that storage system to CloudCasa, and we're going to understand the relationships between that backend storage system and its replication target, and vice versa. So in this case, I have some storage systems that have been added. Very simple to add a new storage system here. Just give it a name. Select the type of storage that that you want to add here. So that the new one's going to be the Dell PowerStore. The endpoint URL that you're going to use to log into that storage system, and then the username and password. So just like logging in to your storage system from standard web browser, right? These are the information contents that you're going to provide to us. And once you've provided that to us and we've linked and validated that storage system, we're going to be able to see kind of the relationships that are already there from a storage perspective, right? So we see just some system information here. If I want to take a look at some of the replication targets, I know that the PowerStore 7000 is has a replication target, one volume of the 6120 here, and that's at this 1200T, and then vice versa, the 1200T has a replication target of this storage system here, right? So you can see how we're now forming the relationships between the cluster or the storage systems at this point, but we need to link these to clusters, right? So we validated this, now we can link them to clusters. Let's say I have a cluster here that is linked to that storage system. So my Parasite A, I can link it to one or multiple storage systems here just by pulling that from the drop-down list here. And once we know that the cluster has been linked and connected, storage system is accessible, we now understand the underlying relationship between the cluster and the storage volume. So to create our disaster recovery plan, it's just a matter of choosing our source and target clusters. The same thing for our failover and failback plans. So we'll just create a new disaster recovery plan here. We'll select our source cluster at site A that we know is linked to the 7000T. So we'll pull that from the drop-down list. We can now link that or create a DR plan to bring this application up on our destination cluster at site B, which we know is now linked to 1200T. And because we understand the underlying relationships of the applications and the persistent volumes that they're going to be associated with, this is where we can just define what we want to bring up in our disaster recovery plan. It could be an application running within a namespace. It could be a deployment. It could be a stateful set that you have defined. It could be a VM, right? You can select those objects that you want to add to your DR plan, create that DR plan, and now define a recovery job for it, right? So in our recovery job, let's say I have a test that's associated with my DR test 1 plan. This is going to allow me to recover those workloads that I've selected, or recover all workloads at a click of a button, right? So, or if I want to just isolate that to a specific workload from that recovery plan, I can do that. I can transform my restore here. So this is part of that enable restore modifier version or functionality that we have, or that we have had from the beginning from our CloudCasa deployment in terms of just traditional restore. But this is where you upload or change around the resource definitions just by simply uploading new YAML file that's going to be able to override the existing YAML within that definition. And for VMs, we have other transforms that are going to be applicable there. So that is, our, disaster recovery in a nutshell, right? The key being is that there's a new tab. You're just going to link your storage systems that we have support for today, link them to clusters. We're going to index. We're going to understand and develop a map between the cluster and the underlying storage topology, and then from there you're going to be able to create your plans and recovery jobs. So this is just an overview here. We do have some. I want to point out that we do have some videos on our YouTube channel here. That is, we do 2 parts: part 1 failover, part 2 failback. But this is a kind of a live demonstration that we can with the HPE Electra using a NFS server application that's running on OpenShift, right? So we're creating files on that NFS server. The storage is all being replicated over to a different Electra device, and then we bring that up in our failover, and then we bring it back on our failback. So I'd recommend, if you want some more details here, just check out these videos on our YouTube channel. We have some other videos on resource automation, deployment automation, granular file recovery from VMs or from PVC. So a lot of great content here if you're looking to get into more detail on that. But really, we just want to focus here on the new features with disaster recovery planning. What our future looks like in terms of adding more storage providers into this framework now that we have the framework actually built and able to establish those API calls to those storage providers.
I think you're muted, Sully.
You're right. I'm double muted. I got up to let the dog out, and I didn't want to accidentally make noise. So there's a question that came up in chat. So how friendly or integrated is this with SRIOV networking workloads? Like network function, virtual or virtualized network functions, containerized network functions, etc. I think that probably also would apply to things like, if the workload is using a UDN or the namespace, it's expecting a UDN to be there, something like that, sort of dependent network or other configurations.
Yeah, that's a great question. So with regards to networking and kind of the infrastructure, let's say the infrastructure, the host, the node group topology that would be created beforehand, we're not doing anything from an infrastructure management deployment. So that would include networking. That would include the nodes, the node group configurations, right? We're just really at this point talking Kubernetes aspects of it. So those networks and their applicable or related custom resource definition or definitions themselves would already be created from a cluster perspective from the get-go, right? So what we're doing when we restore is just, hey, we're expecting this network to be out here. If the network doesn't exist, then we're going to throw an error. But with regards to the overrides, you're going to be able to point to, let's say, a new network configuration that is already created on the cluster, if that makes sense, right? So we're not doing anything from I guess, an infrastructure creation perspective. We're assuming that this is all created, but it's going to be through the overrides are going to be through the YAML configurations that we're going to be just pointing to a different network, different data store, or storage class, etc.
Yeah, so I think a good distinction to point out is it's a workload protection and recovery system, not a cluster configuration or a cluster protection and recovery system. And
Right.
when we
Exactly.
talk about like, oh, my workload, my application needs a UDN, that is outside the scope of doing the infrastructure, the cluster level configuration and deployment and all of those other things.
You explained it better than I could, Sully. So yeah, that's perfect. Yep, exactly right. I will plug in some cases we are able to do a full stack recovery where we take some assumptions or make some assumptions on a cluster that we want to build, and this is more towards recovering or scanning cloud accounts. So these let's say you want to bring up a cluster within Amazon or Microsoft or Google, right? We have the ability to create a cluster on the fly, making some assumptions. The users do have some customizations to how they want their cluster to be built, the number of nodes within the node pool, let's say, the VPC networking configuration that they want to deploy. But we'll make some liberties in terms of creating that cluster, and once we have a working Kube API server on the destination side, we're going to be able to restore those workloads and applications.
Yeah, and I think that's fair, and that's in line with exactly what we talk about with OpenShift, agnostically. GitOps is sort of the same way, right? If let's say it's a stateless application and I'm just using GitOps to redeploy all of those things, by default, I'm just protecting the workload. I'm just recreating the workload. Can I extend it? Can I also do other cluster configuration level things inside of there? Yes, but you don't necessarily want to do that blindly either, because source site uses VLAN 12 for connecting my virtual machines out there. Destination site uses VLAN 73, and so I can't just use GitOps, create a new cluster, and then blindly reapply the old configuration, because there might be infrastructure things that don't apply or are different, and so
Exactly,
it still requires I'm going to use an AI term. It requires a human in the loop in order to make those decisions about what is potentially different infrastructure.
Exactly. Yeah.
So Martin, this is probably just like pie in the sky question here, but like, do you have anything like roadmaps where like there's some type of like discovery where you can compare a source and target cluster where you're like, hey, look, you've got VLAN 12 on your source, right? And then you want to go to VLAN 73 on your destination, or you've got certain hardware components that your workloads are using on one side and it doesn't have it on the other side. Like, is there any plan to have like that kind of like mind meld where it says, hey, your infrastructure physically doesn't match, right? Like, so like this workload would not be a good, candidate to be migrated or DR'd. This wouldn't be a good DR workload from this cluster to this cluster, maybe look it somewhere else. So that way you're not starting a DR process and then finding out like, hey, nothing works because I don't have GPUs on this side or whatever. You know what I mean?
Yep. Yeah. So I'm sure it's been talked about. I think it's probably further down the road. I think we want to get some more integrations in place before we start, doing those types of, let's call it error checking or just sanity checks within the job definition. But I think, from a one-click perspective, right? You're going to be building out your DR plan. You're going to be running it the same way every single time, which is just, hey, once I have my DR plan built, I can just run that failback or failover operation automatically. So a lot of that is going to be determined upfront, right? So when you run it for the very first time, it doesn't work. We're going to show the error messages. We're going to be able to work through those errors as to, hey, you have some node affinity set here. This network VPC doesn't exist over here, and we're going to help you build the overrides into that. So, and you're going to incorporate those new override YAML configs to that workload, that DR plan, and assuming nothing changes from beyond that, this is going to be a workflow that you can run on a repeated basis, right? So that a user that might not be familiar with OpenShift or Kubernetes, they're going to be able to go into the user interface. They're going to be able to say, hey, I want to fail over this application and just run that workload that's already been predefined by a Kubernetes administrator.
Gotcha. Yeah, I was telling you in the pre-show, I think like we were doing, my team's been doing a lot of work with DR, and like one of the things that I was doing is I'm trying to use like a completely GitOps approach to, this failover and resync, right? And so like just seeing the GUI here and having a little button, I'm like, I'm kind of jealous because I had to build it into Argo CD through like a resource action. And I mean, it works and it's glorious, but it's like, it was painful getting there. And to have something that like, it's really nice and clear where you can just go and click it and then it does all the magic for you, it's pretty cool. So I'm jealous. All right, awesome. Is there, so like what's next? What are you guys working on next? Not to like downplay you guys getting in the DR game, but like like what do you guys, DR is obviously a thing. It's everybody's talking about it right now. So like what are you guys doing as well as DR?
Brian, you want to go first there?
Yeah, I mean, right now the focus is, and I'll touch on some things with DR first, right? Obviously, adding in additional storage vendors, like Martin said, Dell is on the horizon very soon. We've talked to NetApp and a handful of other storage providers. Things like re-IPing, asynchronous replication, all that stuff is on the roadmap to kind of improve the DR story. We got funny. I was actually watching, just rewatching the previous podcast that we did earlier this week, just to kind of catch up on what we shared. But there's always talk around AI, right? And so being able to provide backup support for AI workloads, OpenShift AI, I think that's the focus now, is because that's going to be more top of mind than ever, and so adding to some of the backup workloads around artificial intelligence in addition to DR. Been kind of focusing on, but Martin, anything else that comes to mind?
Wait. You mean to tell me that you're working on AI?
Yeah, right. Believe it or not.
Yeah,
Believe it or not.
No, AI is nothing. No, but yeah, so I mean, it's that level of application integration. We're kind of seeing where the market's moving or trying to move, right? And I was going to take it from a different perspective here, because we've been a data protection company for a long time now. We're 25 plus years within the industry, right? So, we cut our teeth on traditional, so think legacy tape-based data protection, right? Archive to cloud, that type of thing. We built our own storage appliance. So we have different products within our portfolio that encompass that level of, on-prem type traditional data protection. And I think, some of the talks that we're having now is, well, how can these two worlds meld, right? So when you have applications or environments that are running within the multi-cloud, right? We're trying to be cloud-based agnostic. We're trying to be storage agnostic. We don't want to tie ourselves into any, or pigeonhole ourselves into any one major area, but linking these types of infrastructures where we have, users that might still have legacy infrastructure, Windows and Linux machines that are running and now want to migrate cloud native. We have data protection products for both. We don't necessarily have, the tools necessary to help us get between the two. I know Red Hat and OpenShift, does have some of those tools, but to do it at scale, like in terms of bare metal restoring, to a containerized VM. I think these are some of the conversations that we're having in the background to help, just build up some tighter integration between our portfolio and allow users to continue to make that transition and define what, workloads they want to run cloud native and what workloads they want to run on physical hardware infrastructure.
And forgive my ignorance. This might be a basic question. Does CloudCasa protect artifacts? So like container images. Like the thought process in my head is, I have a pipeline, a Tecton pipeline that's running in my cluster. The output of that is a container image, along with a deployment definition, for actually deploying that. If I recreate that at the recovery site, I now will probably have to wait however long the build pipeline might take in order to get that artifact back to then restart my workload, which could be, a significant period of time depending on what's happening there.
I want to say that we do. The worst case scenario is that we can point it to another container repository image or container repository during the workflow, where you can, whereas when we're restoring that application, we're going to be able to just say, hey, we can't get access to this container repository. But I know that the same image exists over here. This it's been used quite often in our air-gap-based deployments, but yeah, I'm pretty sure that we do, but let me double check on that for you if we back up the images themselves from the container repository. So
yeah, it was a thought that came up because somebody asked me recently about basically that exact scenario. Like, hey, like my application takes an hour plus if we have to do a rebuild because it has to go through a bunch of basically validation tests, you know, like thousands and thousands of validation tests, followed by waiting on things like ACS to come in and do the security scanning on the base image and like all of that other stuff that happens inside of there. And so it can take time just to be able to, you know, hey, we recreated all of these objects, but we have to wait for the build to finish before we can actually deploy the application. You know, it might be one of those things of going back to like, you know, it's considered infrastructure to the cluster and therefore it's excluded, but it was an interesting thought.
Yeah, and depending on where they're pushing the image too, right? If they're pushing it into the local OpenShift registry, you could have that as a backup or as a restored service that you're moving across, you know what I mean? And then the image would be there, but yeah, it's interesting.
Well, it's a conversation I've had with virtualization administrators because, you know, we don't think in terms of stuff like that of, you know, oh, I have, you know, an air-gapped deployment. I have my cluster that's up and running on the destination side, but oh, I didn't realize that I needed to also include, you know, the OpenShift virtualization operator and the container images that it needs. So, you know, how do I go and deploy those things? And that's clearly out of scope for something like CloudCasa, because that would truly be considered infrastructure cluster configuration type things. But you know, the recovery process is more than just I have this file, right? The VM disk, I have this YAML, the VM definition. Let me just stand it back up. There's a lot of other components inside of there, and I think, you know, folks who've been doing Kubernetes native applications for a while, you know, realize, you know, oh, I shouldn't just put this container image into the internal OpenShift registry. I should be publishing it somewhere, you know, an external quay that's already doing its own geo-replication or something like that for disaster recovery. But you know, we're all learning about these things at the same time.
Exactly. Yeah.
Awesome. So Sully, I'll start getting this thing wrapped up. If do you have any like closing statements you want to make or closing remarks?
I don't. It's good to be back. I'm like relearning the interface here, and you know, remembering how to be on a live stream and all that other stuff. And it's been like a solid 3 months or something, Jonny, that you've been running the show all by yourself, and I greatly appreciate that. So thank you.
Has it been that long? I don't think it's been. It feels. I mean, it's been a while for sure. But like, yeah, dude, anytime. And I know you're busy as hell, so like I'm not even like remotely stressing it. So.
Well, I appreciate it. Thank you.
My man. So Brian, Martin, we really appreciate you guys coming in. Before we close out, is there anything that you guys want to say before you go?
No, we appreciate the opportunity. Yeah. Nothing much to add. If anybody's interested, feel free to hunt us down on LinkedIn, go to our website and download a trial. We'll be happy to help you guys kick some tires and show you more about CloudCasa. So.
Awesome. Yeah, and if you're lazy and you don't want to do that, feel free to reach out to Sully and I, and we'll broker the connection for you as well. So that's what we're here for. So again, to go over the schedule, we've got Portworx next week. We're gonna try. There's a couple of labs that were from. I said KubeCon earlier because I'm dumb. I meant Summit. From Summit that are very interesting. So I think that we're gonna try and fit those into our schedule and actually do some technical stuff, and then. Solely, we got to do a 422 thing. But yeah, outside of that, just Portworx next week, and then we'll get the rest of July figured out. Solely, it's good seeing you again, man. You start your beard's starting to get extra chromy like mine, and we're getting old.
Getting there. It's long past that point.
Cool, man. Well, hey, I'll see you guys next week, and everybody have a good one.
Take care.
Thanks, everybody.
Thanks, everyone. Bye-bye.